So hi all, welcome back. And in this video, we'll be talking about inheritance. So in the previous video, we talked about enums. So if you want to have a quick refresher, you can take a look at that video. Or otherwise, in this video, we are talking about inheritance. So if you want to follow along with me, you can just head over to low level design mastery, and then in the oops refresher module, this is the second concept. Sorry, the third concept, that is inheritance. So without wasting time, let's start on this. Okay, so inheritance is one of the core oops concept, right, that you have to master. So the main idea is it lets a new class reuse the attributes and methods from the existing class. This is very important. So whenever you create a new class, it gives that ability to make reuse of the attributes and methods that you defined earlier in an existing class. And then on top of that, you can only specialize the parts that are different. So we'll see all of this with an example, but for now just understand this definition. So this is what we'll be learning. So first we'll understand the easy relationship. What is a relationship? Secondly, we'll see how inheritance helps reuse common behavior from a parent class, right? Third thing is we'll learn method overriding. So where child classes can customize the behavior from the parent class. So we'll see how child classes can customize and override the behavior whenever they're inheriting from a parent class. So finally we'll take a look at super. So super is a method that which allows the child to call the parent logic instead of duplicating it, right? So we'll understand what is super, how should we use it in both Python and Java. Okay, so this is the core mentor model of a inheritance. So inheritance should be an is a relationship. So we'll see that with an example. So a car is a vehicle, right? Obviously. So if you see, this is kind of a is a relationship. So similarly, a dog is an animal, right? So this is also a is a relationship. A manager is an employee, right? So this is also an is an employee, right? So if you see here, a manager can reuse the employee data and behavior, right? And then add manager specific behavior, right? So let's say if there is an employee class which is already defined earlier, then whenever we are creating a new class for manager, this manager can reuse the functionality or the data and the behavior of this employee. But obviously manager has some additional responsibilities, right? So he can customize the additional methods or add methods which are specific to the manager class. The test is very simple. I mean, you can just say the sentence out loud. If it sounds wrong, then inheritance is not probably the right tool. So whenever you say car is a vehicle, obviously it's correct. It makes sense. A dog is an animal. A manager is an employee. So if this is a simple test, so if something doesn't make sense with a easier relationship, then it probably might not be used under inheritance. So take a simple example, for example, a car has an engine, right? But a car is not an engine. So this is not an inheritance, right? A car is a vehicle, right? A car has an engine. It is not is a engine, right? So that means that candidate is not suitable for inheritance. And then now let's talk about the basic inheritance structure, right? So vehicle is the parent class, and then it contains common data and behavior. So for example, if you see here, it contains brand, model, start and stop methods, right? So all these classes are the parent classes. So parent class is nothing but, so once you create another class and then you know extend from the previous class that was created, right? So that class you will call it as the parent class. And the whatever classes you are extending making using this vehicle class, so those are called as the child classes. So in this case, this is a parent class, and then this class is inherited by car and motorcycle. So if you see, car inherits from vehicle, so this is a parent class, and these classes are the child classes, right? These child classes, they share common vehicle behavior, right? So they share this vehicle behavior, But apart from that, they can also add their own specialized data and methods. So for example, if you see car and motorcycle, so they have their own specialized data. If you see car has a number of doors, motorcycle has separate instance attribute called as bike type, and car has a method called as honk, and motorcycle has a separate method called as a wheelie. So if you remember the first definition that we defined, inheritance, make reuse of the code that we wrote. Plus, apart from that, we can also specialize, right? We can also add our own methods to children subclasses. There is no hard rule that we have to stick to only these methods defined on the parent class. You can specialize or you can override too. So we'll see that with an example. So this is a basic inheritance in Python, right? So we have a class vehicle, right? And then we have a init method, the constructor, and then it takes brand, model, and year, and then it assigns to its respective variables. And then there is a method called as getInfo, which says self.year, self.brand, and then self.model. So whatever the three variables that we are passed here, it is just printing them. Sorry, in fact, returning them. Now you have another class called as car, and then this extends from a vehicle class that we defined earlier. If you see, this is extending from this vehicle class, and then you have an init method, right? And then it is calling super.init brand, model, and year, right? And then apart from this, it also is storing one additional data, that is self dot number of doors is equal to num doors, right? So we'll see why are we doing this super dot init, but for now just understand that this is how the car class is making use of a vehicle class. Now you also have a method here that is it says honk, and then it just returns beep. So now finally when you create an object for the instance car, you are passing the brand, model, year, and number of doors, right? So all these things that we are asking here. And then when you print car dot get info, see this get info is returns this, right? Self dot year, self dot brand, and then self dot model. So how does this work? So if you see, there is this vehicle class, right? So vehicle has get info. So when you say car dot get info, because we are this car class is something that is inherited from vehicle class, this get info gets called, right? And then second thing, when you call car dot honk, so honk is a method that is added here, right, on the children class or the on the child class. So this just returns beep. So this is how it works. And another thing to notice, so whenever you create an object from the car class, this super dot init is creating an instance, right? Instance, we are calling the constructor of a parent vehicle class. So that is why when you do car dot get info, you are able to get the this return this thing. So if you see, the child object can use the inherited behavior and also its own behavior, right? So how are you be able to call the parent behavior, that is the get info? Because we are already calling the constructor of a parent class here. So whenever you call super dot underscore underscore init, we are calling the parent class, and then this creates this calls the constructor of a parent class. And then now you can use the functionality or the methods that are defined on the parent class. Okay, so now let's see the same example in Java. So here vehicle is a parent class, right? It holds two common fields, right? And then it also holds this behavior called as getInfo. Now there is another car with extends vehicle to inherit from the parent class. So this is the parent class, this is a child class, and car is extending from a vehicle class. And now this adds its own child specific behavior. If you see, number of doors is something that is specific to car. Same behavior, right? So we added this honk method. So overall, and the mental model is same as Python, common behavior. So whatever the common behavior that you want to abstract, right? So you place it in a parent class, and all the specialized behavior, goes to a child class. So now let's understand method overriding. So in short, a method overriding means The child class provides its own version of a method that is already defined in a parent. If you see the earlier example, there we are creating a new method, a new behavior on a child class. But what if we want to make a change to the behavior which is already defined in the parent class, right? So if you say this, there is a class vehicle, and it has a method called a start, right? So vehicle has a start method. It just says starting vehicle. But now there is another class called as electric car, right? This also extends or inherits from the vehicle class, but it defines another start method with the same name, right? So whenever you just whenever you instantiate another method, or whenever you define another method with the same name as present in the parent class, then this overrides the previous definition, right? So this overrides the parent version. So parent version says starting vehicle, but now because in child class you say starting silently, this overrides the a function that you wrote earlier in the parent class. So when you say vehicle is equal to new vehicle and Tesla is equal to electric car, so that means it creates an instance of this electric car. So when you call Tesla dot start, it uses electric car dot start, not vehicle dot start, right? So why not vehicle dot start? Because this, if you see in the child class, we wrote a method which kind of shadows the method that we wrote on the parent class, right? So this means we are overriding the method that we wrote earlier in the parent class. So now it just calls electric car dot start, not the vehicle dot start. So this is very important. In fact, this is one of the foundational concepts for polymorphism that we understand later. So now let's see Java method overriding. So vehicle class defines a general start method, right? And then electric car extends the vehicle, and then it defines its own version of a start, right? So if you see, same as earlier, right? Starting vehicle, starting silently. And then this override annotation that we specify, so this tells Java and the reader that this method intentionally overrides a parent method, right? So by annotating that with at the rate override, we are saying, so this start, the definition that you wrote in start, this should override the previous behavior that you defined in a parent class. So the concept is exactly same as Python, but Java makes it more simple and easy to read because you are specifying it as an override here. So that's all when it comes to Java. So now let's understand multi-level overriding, right? So now let's see with an example. So there is a class called as vehicle, and then there is a method called as fuel type. Secondly, there is another class called as car, and then it extends from the vehicle class. See, we wrote vehicle here, and then we wrote a method where its name is exact same as a parent method. So that means we are overriding, right? So this returns gasoline. And then there is another class called as electric car, also has fuel type, and then it returns electricity. So if you see this, right, so whatever the generic or general behavior that we want, we write in the parent class, right? But the actual specialization for this goes in the child classes, right? If you see car, electric car, so both these things are just defining the method which is already defined in the parent class. Fuel type, so means we are overriding whatever is written in the whatever is written in the parent class, and then we are specializing it as per the child class that we define, right? So when you print electric car dot fuel type, it returns this electricity. So let's understand super now. So we saw this earlier, but let's take a deep dive, right? So super is used, when a child wants to reuse the parent logic, right? So this is a child class, this is the parent class, vehicle is a parent class, car is the child class. Vehicle car is extending from a vehicle class, right? So if you see a vehicle constructor it initializes brand and a model, right? These things are common across all a vehicle, right? So such things we can initialize at the parent level. So the data which is common across all vehicles, right, we can add it in a parent class. Now, if you see cars constructor, it receives brand, model, and number of doors, right? So it means it needs the parent setup plus one extra field, right? The number of doors. Now, when you call super.init, it calls the parent constructor, right? So whenever you are doing this super.init here, that means it is calling the parents constructor, right? So this avoids duplicating brand and model setup in the child. If you see here in this child, when we are taking brand and model, we are not writing self dot brand and self dot model here, right? So we are only writing self dot no self dot number of doors, and then we are assigning it to the number of doors that we are getting here. But the rest brand and model, so how are we making use of that? So we are just calling the parent constructor, that is super dot init, right? So this avoids duplicating brand and model setup that we did on the parent class again on the child class. So the best practice is to use super instead of calling the parent class directly, right? So it handles inheritance correctly, and then especially when hierarchies become more complex, right? So this is just a very simple hierarchy like car and vehicle, right? But whenever this hierarchy becomes complex, making a use of super makes more sense, and it is easy to debug too. Okay, so now let's see how we can use super with Java, right? So it also uses for the same parent constructor idea. So we have a vehicle class, right? And then we have a constructor which takes brand and model, same as we saw earlier. And then car extends vehicle and it has its own constructor with one extra field, that is the number of doors. And then super calls the parent constructor, right? So before you call, before the car initializes the number of doors, whenever you are calling super, that means it it calls the parents constructor, and then we are passing brand and model goes here, and then it initializes brand and model. So there is no need to write this logic again in the child class. You can use the code that we wrote in a parent class, right? So super calls the parent constructor before car initializes its number of doors. We saw this, right? So if you take a look at a full snippet, Java and Python just share the common design pattern, right? So we just set up the parent first, and in the child we call the super. That is, we call the parent constructor before whatever the specialization that we want to do in the child classes. So finally, so now let's understand how to extend the parent behavior. So super is not only for constructors, okay? So we can also use it to extend the parent method behavior, right? So we'll see that with an example. So employee has a getinfo method, right? So what it is returning, it is returning self.name and self.salary, right? Now we have another class called as manager, right? If you see, there is another class called as manager, which is extending from employee, sorry, which extends employee, right? And then here if you see, manager overrides get info, right? So the method name is saying is that it means it overrides the get info, but here in this case it does not throw away the parent implementation, right? So if you see this get info, it is overriding the parent behavior, right? In the base info we are calling super dot get info, right? So super goes to employee dot get info, returns self dot name and self dot salary, that we are getting here, right? And then here we are returning base info, and then we are also calling the team here, right? So we are extending the parent behavior. So we are not just overriding, right? So get info we are overriding, but we are extending in this case, right? So it calls super dot get info, and then it stores that result in the base info, right? So we are calling super dot get info, store the result in the base info. So now if you take, now when you see the full snippet, right? So this manager class reuses the parent output and adds something called as a team size. So we are extending the behavior of a parent class. So this is very useful pattern. So you call the parent method and then add child specific behavior to that. Okay, so time for a real world example. So, let's take a small example e-commerce and then see how it works. Okay, so we have a parent class called as product and it has name, price, and get price methods, right? So usually, we what do we store in parent class is things like common data or common behavior, right? So we add that to a parent class. Now, physical product is a child class, right? It is a product, right? Obviously, it is a product because it is, it is inheriting from a parent class product. So it is also a product, but it adds additional details, right? Like weight and shipping cost. And then we have a digital product, which is also a child class, which is inheriting from a parent product class. So that means this is also a product. This is also a product, right? Both of them are products, but they also have their own behavior, that is the download URL and then send link, right? So both child classes are products, but they specialize in different directions, right? So one is a physical and second is a digital. So common concept stays at the top at the parent class, and then specialized versions stay as a child classes. If you see physical product, digital product, all these things are you know stay in the child classes. There is this representation where parent class stays at the top and the child classes kind of inherit from the parent class, so like this. Okay, so here is the example code. So we have a class product, right? So it owns the common fields as we talked earlier, name, price, and then SKU, right? And it also has a default method called as calculate shipping. Just for default we are just returning it as 10, right? And then there is this physical product which inherits from a parent class product, right? And then in its constructor we are calling the parents constructor, passing on the name, price, SKU. So that means this variable in initialization happens. And apart from that we are also having one additional attribute, that is self dot weight. Now finally we have a digital product which also inherits from a product, right? It also calls super dot init, and apart from that it also has download URL, right? Same as earlier. If you see here, physical product has this self dot weight, and then digital product has self dot download URL, and then this calculate shipping, if you see, we are overriding and then returning 0, right? It makes sense, right? If it is a digital product, right? For say, let's say you are selling a book, right? So there is no shipping cost, right? We just email the PDF to the user. So we are just overriding the method that is defined in a parent class, and then we are returning 0 here. So now if you take a look at a full sketch, inheritance keeps all common product fields at one place and lets each child, whatever the child that you are defining here, physical product, digital product, etc. It lets the each child only add whatever is different, right? So that means we are just making reuse of a code, right? So whatever additional we are defining in child class, but apart from it, the rest we are making use of the behavior and data that is defined on the uh, parent class. So this is kind of class hierarchy that you might discuss in many low-level design interviews. Okay, now let's see multiple inheritance. So Python supports multiple inheritance. That is, where is one class can inherit from more than one parent, right? So there is this flyable class, right? So one parent gives the flying behavior. There is another parent consider that gives a swim behavior, and then there is a duck class which inherits both the fly and the swim, right? So it is inheriting from a multiple parents. So this is very powerful, but we have to use it carefully, right? So whenever we are inheriting from multiple parents, it can become harder to know from where is the method coming. Is it coming from a flyable or is it coming from a swimmable class, right? So that is something that you have to keep in mind. So there is another small concept called as method resolution order, right? So this applies for Python. Let's say you have a class A, that defines a method at the top of a hierarchy, and then B, which is extending from A, right? So we have a class A. Consider that we have a class A, and then we have class B, which is extending from a class A, and then it also has its own method. Same, it is overriding C. And then C, it also has, it inherits from A. Sorry, so this is something like this. We have A, B, and then C, right? So it also has a method overriding the behavior that we defined on class A. And then we have class D, which is inheriting from both B and C, right? B, C, and then D. So now when you call D dot method, see, class D is inheriting from both B and C, right? So B and C, it is inheriting from both this. Now both of these classes have the method defined, right? So when you call dot method, what should it resolve to? Should it resolve to B or should it resolve to C? One thing to notice, it will not resolve to A, because we are, even though B and C are inheriting from A, we are overriding, right? So only thing possible are B or C. Now should we return B or should we return C, right? So the practical rule is Python checks parents according to the class resolution order. So if you make use of multiple classes, right? So whenever you are inheriting from multiple classes like B and C, you are inheriting from B first, right? So it means the resolution order of this method, first it picks the method that is defined in the class B, and then it returns B. So now the key takeaways. So inheritance lets a child reuse its attributes and method from a parent class, right? We saw this. And then second thing is, it should represent is a relationship, right? So manager employee, overriding the child classes, help the child classes to provide specialized behavior. We saw this. The generalized behavior stays in a parent class, but the specialized behavior goes to the child class. Super lets child class call the parent class logic safely. We saw this with an example. And finally, multiple inheritance allows more than one parent, right? We saw what is multiple inheritance, how it allows more than one parent. So on this multiple inheritance, there is one more small point. So if you see, Java does not support multiple inheritance for classes, but however, you can achieve similar functionality using interfaces. So interfaces is the next concept that we'll be talking on. So we'll see, how we can do that. But as I said, in Python, it is possible to inherit from multiple classes. And how does this resolution happen? That is this MRO order that we saw in the example. Okay, so finally, this MR order decides which parent, right, which parent method to call when there are multiple options. So this is used. So if you want to practice, you can just follow this inheritance article on low level design mastery. Pick language of your choice, C, C, Ash, Go, Java, Rust, right? So pick your language of your choice. You can copy this code sample, or you can just see this code sample, keep it aside, open your IDE, copy this code, paste there, make few changes, add a new method, or override a method which is already defined in the parent class, right? So play with these examples so that you'll understand this concept better.